John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporland's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on. I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporland.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporland signing off.
Hello guys, this episode is brought to you by Fieldpiece. Fieldpiece's next generation of vacuum pumps will cut down on evacuation time and make oil changes on the fly a breeze. They are lightweight, durable, and feature 4 inline ports plus a large oil reservoir. Get pumped about these 3 new Fieldpiece vacuum pumps available at distributors now. Learn more at fieldpiece.com or follow us on social media at Fieldpiece Products. Thanks again, and thanks for listening. Alright guys, question number 3 for the month of August. What is the pressure and temperature at which CO2 becomes supercritical? Let me know. Send me the answer to arpgiveaways@gmail.com. Have a great day.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of the day or night to check stock on your favorite brands, such as Copeland, Sporland, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2 United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live-to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
Hey, y'all. Hey, what's going on, everybody? Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. You guys got about 20 minutes. Kevin's got to talk about some stuff. Take it away, Kev.
No, if I go on a rant, you're gonna yell at me.
Well, I mean, I can edit. That's fine.
Yeah, that's way too much editing at this point for how mad I am right now.
Is it really that bad this week?
Oh yeah.
Why?
Yeah. because people don't do their jobs.
Is it they don't do their jobs, or are they uneducated on what they're working on?
That's both. It's both. Yep.
Why do you say that?
Because nobody cares anymore.
Do you think it's because everyone's toast? Because it's it's been up plus 100 degrees everywhere for the past 2 months.
Yep, and everybody can take these SLAs and
I was just talking about that, and that's one of the reasons why guys are so much toast is, hey, you need to be here in 3 hours. Okay. And you got 3 stores down, so we'll get there. We'll get there as soon as we can, right?
Oh, you missed your SLA time. You're getting a fine.
Yeah, it's getting kind of bad with that. That's one thing I'm just, I don't know. I don't agree with how demanding some. I mean, if rack down, I get it. You know what I mean? But if you have 1 case down, pull it. You got a walk-in cooler. You got a walk-in freezer.
Oh, SLA for 2 hour for a water leak at 3:00 in the morning. Like,
all right, that one I'm borderline on. Are you talking on the floor, or are you talking in the kit, or like in a walk-in?
Like, it doesn't matter. It's 3
no, it does.
Nobody's in the store.
Well, they just want to make sure that you get there right at 6 a.m. then. Well, how is the call getting generated then? Because, I mean, how do you have a water leak on the floor at 3:00 if there's no one there?
Talking, but like there's no customers there. I'm sorry. It's a water leak. Put a cone up.
Yeah, but it's an insurance problem.
Call a plumber.
Not if it's the case leaking. That's our problem.
Yeah, well, just vacuum the water out of it then. Clean your cases. There's no reason that somebody should potentially die on the way to a call for a water leak.
So I have a question for you. Are you working with the service department this week, or you're working your normal digs?
I am like in between both because we have like no construction work.
Really?
Yeah. There's no cases because manufacturers don't make cases anymore. They just make promises that they're going to make cases.
So I'm dealing with that right now. There's a store that needs help with a startup, and they're like, well, when can we start the medium temp side? I was like, the medium temp side will run by itself without any caseload, but if you want to start doing the rest of the transcritical, you got to have at least 30% of the load for the medium temp in order for anyone to open up the low temp side. And he's like, well, that might be a problem. I'm like, why? He's like, well, because I think we have like 7% of the medium temp load. I'm like, problem.
Yeah, we're doing the same thing. We just got all the cases last week, and they want to start the rack on Monday.
Yeah, that's
Friday at 8 p.m.
Did anyone go through the wiring at all?
Oh God, no! Really?
No, I meant. I meant with the company that you work for. No one went there to check out the wiring and shit?
Check out what wiring?
No, the wiring on the rack before they started up.
Well, it's all going to be wired wrong no matter what.
Well,
pretty hard to check on the wiring when you got no controller.
Oh, really? So the rack doesn't have a controller either?
The rack showed up with no boards. I shit you not.
That is retarded.
Yep, we had sent all used boards out of another store. So how well do you think that's going to work?
What are we talking about? Microthermal or CPC?
CPC.
Bust out the control time.
It's just like a fucking whatever. Yeah, because I'm sure every one of those boards is good.
I got a bunch of them yet somewhere.
I have a lot of them if anybody wants to buy them. All right, guys. So let's hop into this before I just fall asleep because I'm exhausted. Let's hop into this. We're going to go over starting up the first part of starting up transcritical racks. Like anything, obviously safety. Everybody makes this into this like huge ordeal that you're going to kill yourself. I mean, it's not very much different than a normal DX refrigerant. It could still blow up. I mean, you just got to take precautions. Don't trap liquid, yada, yada, yada. Dry ice is like half of a myth. I mean, you're not going to make dry ice. Unless you're pumping on a liquid shell or a receiver or something like that. I mean, you're not going to purposely make dry ice. They make it out to be more of an issue than it really is. It's like stop, drop, and roll when you're like a kid. They make it seem like you're going to use that all the time.
I had to use when I was younger. I had to use the Mr. Yuck a couple times though. My parents would leave stuff out all the time.
It makes a lot of sense the way you are. So, all right. We'll start this up. Like, first things first, guys, is once it's piped, you need to make sure it's good. So, meaning you need to start pressurizing. So you need to isolate the gas cooler and the TC side of the compressors from everything else. So you're going to close the ball valves. You're going to remove the reliefs, and you're going to pressurize the gas cooler up to like whatever the customer says. I usually go 1,900 pounds. I go right under what the reliefs on the compressors are for. So if the compressors on reliefs are like, say, 2,000 pounds or 1,900 pounds, I'll go like 100 pounds under those because I'm not capping off the compressors. That's way too much work for another 100 pounds. I mean, if it's going to blow at 1,900, it's going to blow at 2,000. I'm not really worried.
Well, wait a minute. Don't, because the medium temp or low temp compressors have different reliefs on them. Don't you have to separate that from the system, because that's going to be the reliefs on the compressor are going to be at a way higher pressure on the suction side? You're muted.
The transcritical, you're only doing the transcritical side, the TC side. So it would be the medium temp compressor discharge on all the way down to the drop leg. So you're going to blow it. If you don't have a hydraulic hose, you can go get a hydraulic hose made. They're cheap, like dirt cheap. Hydraulic hoses are, you can get them at any hydraulic place. I usually use that, or you can use 3/8 copper. 3/8 copper is got a like way higher burst rating than you're ever going to get. So 3/8 soft copper, just run it down to the skid pack. You're going to have to use a 12 pack of bottles, and you're going to need like 2 extra bottles on the side, because you're going to equalize what you're going to get out of the skid pack, and that's it. And then you're going to have to use the 2 remaining bottles to get it up that high. I mean, we did a rack of 2,000 pounds. It took like almost 2 skid packs and like a couple spare bottles just to get it up high enough, because once you hit that spot where you're not getting any more pressure out of the bottle, you're done. You got to move on to a new bottle, and there's only 2,000 pounds in those bottles. So you want to get it up as high as you can get it. I usually just take a nitrogen regulator. I take the fucking regulator off, and I just screw it into the tank, and you have the pipe fitting coming out, and I just put a 3/8 female pipe thread to 3/8 flare adapter. No, on the nitrogen regulators, they're like a coned fitting that goes inside. It goes inside. Right. So I just take the regulator off, and you end up with like a 1/4 inch or I think it's 1/4 inch or 3/8 piece of pipe stub stuck in it. And I use that to pressurize the rack, because you don't want a regulator on there. You just want full bottle pressure. So then you just want you just use the hand valve to shut it on and off, get the full bottle pressure up there, and then pressurize that. And then you want to see how long it holds. I generally want the EMS on when I'm doing this, so I could use the transducers to graph everything. That way I know if I'm losing pressure. And then at the same time, I want to know if I'm coming back down the drop leg, make sure there's no pipe plugs, anything like that. And then I'm going to move on. I'm going to pressurize the other part of the system. So I'm going to bring the other part of the system like 150 pounds below the relief. So if the receiver reliefs are 650s, I'm going to bring them to like 550. And I'm going to let it sit, and I'm just going to pressure test it. I'm testing it. I'm not really testing to see if anything blows on the side. And that as far as that goes, that's for the medium temp and the low temp. Just let it all go to what the receiver pressure is. So I'm just really just checking for leaks at that point. I want to make sure all the leaks, there's no leaks, nothing. And then I'm going to spend a meticulous amount of time making sure every transducer is tight and on there and not leaking. 80% of the leaks we have are all on the transducers. So before I pull vacuums, I put all the transducers on, and I get them all reading and all set up, make sure they're all reading. And then I make sure that none of them are leaking with pressure on them before I pull vacuums. And I'll go around and valve them all on, because that is the number one thing. You want to make sure they're all valved on and reading pressure before on the nitrogen before you do anything. So once you get everything pressure tested, let it sit for 24 hours. Pray to God you aren't chasing small little tiny leaks on transducers and packed angle valves and 4 coils that aren't brazed up completely that somehow made it out of the factory.
Really?
Oh yeah. Like U-bends, like not even finished brazed.
That's amazing.
Yeah. Yeah, of course you got to rip the whole case apart because all the wires are on that side. And
I guess you've done this a couple times recently.
Yeah. So
well shit.
Yeah, and then so once you get all that done, what you're going to want to do is you're going to want to make sure you get your 24-hour pressure test and then blow it down. Now, what I do is, because every one of these racks is so filthy dirty, is I take and I try to blow it down out the liquid core. So I'll valve off the liquid shell dryer if it has a liquid shell dryer, or the suction shell dryer if it has that. And I will blow all the nitrogen out of that. I'll pull the plate off and I'll blow it down that way. The reason I do this is because there is going to be a ton of shit in that tank and the oil separator and everything else. And I want it all to blow out and blow backwards out of the suction shell dryer to try to get all the slag and everything else out of there I can. Like, you would not believe what's in some of these racks. We found pieces of weld rod, chunks of fucking slag, rocks, a rag. I mean, like the most
welders.
most of the receivers that they're getting are just like nasty, dirty, like just vessels. Like, I mean, they're industrial vessels and they don't clean shit. I mean, it's bad. So we were sticking magnets on the outside of the shell dryers to catch all the metal.
So what? I'm thinking. All right. So the transcritical racks you've been seeing, you obviously have to put the suction shells in before you do. Do you do that before the pressure test so it catches everything in there, or you just try to get it out through the suction shell?
Suction shell or the liquid shell, depending on what manufacturer it is. Hill Phoenix is the only one that uses the suction shell dryer. Everybody else uses liquid shell dryers. So it just depends. I mean, I don't put it in before. I just usually let it all blow out and then just deal with it because it's not going to catch much. And then what I do is I start the vacuum process. Now with me, I want 1/2-inch packed angle valves everywhere. If they're not there, if we have spare stubs, I put 1/2-inch packed angle valves, and I use the blue vac hoses with we have a 32 CFM Welch pump. It's a like rotary vane vacuum pump. I mean, rotary vane vacuum pumps are the best you could buy, especially the big ones like that. They'll beat a belt drive any day. So what we do is I generally pull the reliefs. So on the flash tank, I will pull one relief off the relief tree if you have one. Depending, the last 2 racks that I've started up, they had no relief trees. So you blow the relief, you blow the charge. No comment. So I will pull the relief and I will thread in usually a 1/2 by 1/2 inch male pipe thread by male flare, and I'll put a blue vac hose right in there. So that way I'm pulling full flow 1/2 inch right off the top of the receiver. And then I'll put one on the suction headers, and then I'll put one on the drop leg. And then on a TC discharge if I can get it. And then you'll pull down the whole rack that way. And then
couldn't you pull, usually how they were piped up, couldn't you pull, because I don't know, the racks that I've seen, that typically they put all the reliefs in the same area. So you could basically hook up to both of the reliefs, right? That do all the sides where where everything is, right?
It depends on if they have relief trees, and like I've seen a lot of them like hills and put relief trees in the suctions. So there's no relief trees on there, but like the discharge and the TC side discharge and the receiver, you definitely pull both of those, and you'd be surprised how fast it's going to pull. Pulling on the flash tank's more important than anything, because that everything checks backwards towards the flash tank. Every valve and everything else, everything points back towards the flash tank. So once you lower the pressure in the flash tank, it's going to go backwards.
Are you overriding the HGV and the BGV?
I usually do not power them up until they're mid-seated. I don't power them up until vacuums are done. Okay. So I leave those off until vacuums are done. Okay. But if there's a fault, they automatically open wide up.
So you could potentially just disconnect the transducer that's connected to the 326, and then basically it would open up both valves anyway, right?
Yeah. I mean, the flash gas bypass valve, you really don't care so much about. I mean, because you're already pulling on the suction anyway.
Yeah.
But, yeah, the drop leg, I mean, you can. I usually like to try, and I'm pulling on different sections that I could throw the micron gauge on there and see where I'm getting my pressure drop at. But then I'll throw the micron gauge, one at the rack, and then one at the one of the cases, and see where I got my good vacuum at. So then once we go through there, you're pulling your vacuum. Now you want to start testing everything. You want to start checking pulse valves or EEVs and driving them open from the case controller, driving them closed, making sure that one's right, checking temp sensors. I do not, go through the rigmarole like ice test and temp sensor, especially with Emerson stuff or Sporlin stuff. Anything with a 10,000 ohm transducer or temp sensor, especially on a case controller, I'm not wasting my time with that. They're usually accurate. So what I'm doing is to test them is I will spray them with duster to make sure I have the right sensor. So I'll spray
the suction temperature on the suction temperature and okay, gotcha.
Air, termination. So I'll do all those, and I'll go through and I'll take duster, flip it upside down, spray it in the honeycombs, and you're good to go. And then spray it on the suction line, and I'm watching my computer or my iPad, depending on what it is, and I'm going through and I'm checking each case controller individually. Go ahead, Brett.
So let me ask you, because there's different ways. So I know Kevin's saying he's just grabbing his tablet. If you are connected to the controller, you can use TeamViewer on your laptop to basically communicate, or no, not TeamViewer. Yes, TeamViewer. You can basically use that so you can see whatever your computer has. So you can actually connect to your computer as long as your tablet has Wi-Fi, and you can connect to it and see what the controller's doing. And for the most part, you can control the controller through the tablet that's working through your laptop. Is that how you do it, or you do it a different way?
It depends. I mean, just watch how you're doing that, because you'll get a nasty email threatening a lawsuit if you're not using it for home use and not paying for a license.
Really?
Oh, yeah. I got a real shitty email from them saying that if I didn't buy a license, I was going to be turned into collections, basically, because I was using it for commercial use. Yeah. Yeah, you can use TeamViewer. I usually just set up a Wi-Fi router, so I got my laptop. I'm just walking around the store with it. If it's an E2 or Danfoss, I'm just walking around the store with it, so that way I could easily, I don't have to mess with it on my phone as much. I could just easily pull up the case controller and then go. I'm going from there. Here lately, it's been the SC3 stuff, so the actual physical checkout's a lot easier. It's just more of a pain to get them online when you don't have a gateway.
Even with work, I guess, yeah, because there's parameters of FB set that we can't touch because you need to get a password, which takes 12 hours.
Yes, that's become a problem, and that was a problem all day where they were on a job today, and we're integrating the E2 on BACnet, and we had to do a bunch of addresses and get a bunch of BACnet IDs, and you need a code. And unfortunately, there was 7 different date codes in the controller, so they had to go through and find out what every controller was, before they can sync the dates up to get the daily passcode for all those dates.
Because otherwise it's going to be different. So if no one knows already, the S3C used to have a factory password. They don't want you to have that anymore because they don't want technicians putting their fingers in there and changing shit. So they locked it out where you have to call and get, a code just like you do with the E2 if you don't have the proper access, right? So that's what Kevin's talking about. Because, there's so many of these S3Cs out there now, they're having a hard time keeping up with the technical support and getting, getting everyone answered. So I'm sure a bunch of you guys have sat on the phone for, 2 or 3 hours.
Yeah, so that's become a little bit of a pain. Hopefully as all these case manufacturers catch up, they're all going to be the same version, so it should be the same. But those are a lot easier to test because, obviously you could just hook right up to the Tech Check app and you could, boom, easily check that case real quick. Look at it, see the discharge error, see everything else, test the pulse valve, test the EEV, you test it all. So the biggest thing, if you got EEVs, make sure the Sporlins with that new collar. I see probably 1 in every 8 cases with a bent pin. So what the manufacturers will do, they go to put the that M12 collar on there, I think it's what it's called, and they just jam it in there and they end up bending one of the pins. So if you got a valve, I usually just grab them. I'll force them open and force them close, and I'll just grab them. And if I feel the motor moving, I know I'm good. If I don't, then usually the first thing I'm going to do is pull the pin or pull the collar off and check the pins. And then usually just grab a control screwdriver and pray to God you don't break it off.
That duster's actually a pretty badass idea. I've never even freaking thought of that.
Yeah, we usually a Costco will do all the microthermal sensors. We'll go through 2 cans of duster. Works great. It's got a 5-second delay, and then all of a sudden it just shoots way down to temp. It'll even low temp stuff. You'll see the temp move.
That's badass.
That's how I verify them all. 10,000 ohm or temp sensors usually aren't off by a degree or 2. They're usually not.
You're just mostly verifying the placement by just spraying it. The important ones, the discharge air and the suction one.
If it's Novar and it's 2,000 ohm transducers or temp sensors, or Danfoss with 1,000 ohm, those are much more susceptible to line loss, meaning wire loss. For you figure how many feet of wire. Say you got 500 feet of wire, that's going to add ohms to that, and that's going to throw off a temp sensor. Well, when it's 1,000 ohm temp sensor, when it's a 10,000 ohm temp sensor, its effect is a lot less. So, especially when you got case controllers, you're talking some of these sensors are 10 to 20 feet, so you have no loss whatsoever. Don't tell me to stop doing things.
As you're talking, I'll hear click, click, click.
It's a nervous twitch going. So, yeah, with the case controllers, you're going to have very little loss. So you want to make sure all these are correct. You want to make sure the defrost relay energizes. You want to make sure the fans are all running on the medium temp, and the fans come on, the fans go off in the low temp. You want to go through and do all these validity checks before you even start dumping CO2 in this thing. So you want to make sure everything is good. All the transducers read. That's why you want to check those under pressure, because that's the biggest thing on startup is flood outs. Because you have temp sensors crossed, transistors not reading, case controllers messed up. So you want to get everything online, everything ready to go before you go to do anything. So, and then most importantly, turn the drain heaters on for the walk-ins. I don't know how many construction jobs this gets missed, and because the electricians fuck up something and it gets missed, and then we ice up drain lines. So you want to make sure those are on before I start. I usually start the rack. The self-regulating heat tape, it's not going to burn up. So then what I'm going to do is I'm going to break the vacuum. I usually take 2 or 3 vapor tanks per rack, and I will put it in right at the flash tank. So right on the flash tank, there's usually a valve you could hook up to. You're going to dump it right in the flash tank. Just open it wide up. Let it rip. just go straight in the flash tank. I usually just use a black charging hose. So black 3/8 charging hose, and I'll get it up to about 100, 125 pounds. And with vapor, just let it all kind of settle out and like go out through the cases. And I forgot, you got to put oil in the rack.
They don't wait, really? None of them come in it?
Yeah, you got to put oil in the rack. So this is what I do with the oil to test everything. So I will take and I will fill up the oil reservoir with as much oil as I can get in there. And there's a line usually feeding off into the receiver. I'll valve that line off. I'll take a vapor tank of CO2 and I will pressurize the oil reservoir. And the reason I do this is I will force the OMBs or OMCs, or if it's microthermal, I'll force the oil solenoids so that way I could watch them fill. So when compressor 1 calls to fill, it's filling compressor 1. When compressor 2 calls to fill, it's filling compressor 2. So that way I know the oil system's good before I start. I won't put oil in each individual compressor. I will let the reservoir do it and the OMCs do it on their own. And I do that for even DX racks. That's how I fill those up too. I fill the reservoir up. I put the vapor refrigerant pressure on there, and I watch the oil floats fill, and I watch everything fill. So that way I can test everything. Go ahead.
When are you doing that though? Because you went back to it, so I wasn't sure what step.
I do it as soon as I break the vacuum with vapor. And then,
okay, so get it up to 150 pounds in the flash tank and everywhere else, and then basically dump some additional vapor into the separator where you already have the oil set and overfilled, and then basically watch because you're pressurizing so much, it's going to start feeding like a normal system because the other part of the system is going to be lower pressure, so you can actually see the oil system run before the pumps have to actually run.
Correct, and then you're gonna put your liquid cores in. Get your liquid cores in if you have them, and then you're going to pull a vacuum on those real quick, and then now you're ready to start charging. Then I'll bring out the liquid. Now, you want to make sure before you start charging liquid that you zeroed out the high pressure valve, you've forced the flash gas bypass valve, and you feel it moving, that you verified all the transistors on the rack. You unplug them, the right one unplugs. You bump start the compressors, meaning like you put a little bit of gas in there and you force the compressor on. Make sure it's wired right. Make sure it's grounded. You test all the inputs and outputs in the rack, the hot gas bypass if it has it, liquid injection if it has it. Go ahead, Brett.
Obviously, do yourself a favor, check the VFD for sure, and also check all your high voltage connections on your compressors. I've heard
I torque
that's
everything.
Been an issue.
Okay. So I go through with a torque screwdriver, and I torque every single low voltage wire, every single high voltage wire, every compressor contactor, everything literally gets torqued with a torque wrench and a torque screwdriver. Every single one's loose. Like probably 80% of the stuff is loose. You'd be surprised you start yanking on stuff and it just comes right out. You want to make sure that your oil controls are wired properly. I generally try to test the high pressure controls, see if I can get them to, close the alarm contact if I can. And then I'm going to go through the programming. I don't care who programmed it. I'm going through it. I'm going to make sure everything is in there. Set points are in there. It doesn't look like it's going to explode. I'm going to go through, and if I have walk-in freezers, I'm going to step those up to 35 degrees. I'm going to take the setting up to 35 degrees so it steps them down. And then what I'm going to do is I'm going to shut the low temp pumps off, and I'm going to start charging the flash tank. And I'm going to leave the medium temp liquids off. All the liquids are going to be off at this point. And I'm going to start dumping into flat. Go ahead.
Liquid just out to the cases is off. The rest of the liquid feeding the liquid injection, that's still going to be running, obviously, right?
That off usually. You won't need it. If you're just charging a flash tank, the vapor's going to be so fucking cold off that you're not going to need it. So what you're going to do is I start charging a flash tank and start getting everything in there. I'll get a little bit of liquid in there. Then what I will do is I will start dumping it into the case side of the actual line. So I will either it really depends. If I can get it all in the flash tank and it's going to take it, then I'll keep dumping it in the flash tank. If I have the ability to feed it out to the cases and let it come back to the compressors, I'll do that because it's way faster. So what I've been doing is putting a packed angle valve. Go ahead.
How's your charging though? You said before you started feeding the medium temp cases, you were just letting the compressors run on their own because basically on a transcritical rack, the medium stage should be able to run independently, correct?
Yeah, it'll pull off the top of the flash tank. So like I said, you're going to start dumping into the flash tank as much as you can get in there, and then you're going to come a point where you're going to start equalizing out tanks, and then that's just a waste of liquid. So what I start doing is I dump it in past the flash tank isolation valve. So on the other side, if it does not have a valve, like a packed angle on the outlet of the flash tank, I always add one. I always add a 1/2 inch or 3/8 packed angle, because if we need to pump that thing down later on, it takes forever if you don't have a big port there to drain out CO2. So then I'll shut the flash tank, outlet valve, and then I will start charging post that. So just like a normal rack, you're charging down the liquid line, you're letting it all come back to the rack. I'll usually get 3 balls floating, let it like 3 balls floating to the point where the compressors are kind of like, just maintaining on their own. And then I'll slowly open the low temp switches, get all the low temp compressors on, ready to go. And I will slowly start to bring on the liquid and to start letting everything flow. And then I'll start turning circuits on, a few at a time, 1 or 2 at a time. Go ahead.
Just so you guys can envision this, when he's talking about bringing on the medium temp compressors before he starts, letting that liquid down in the medium temp cases, a transcritical rack on the high stage on the TC side can basically run independent with just pulling vapor directly off of that flash tank. It's essentially enough load for that system to continue to run. Now, obviously, you're not going to have every single compressor running, but it's enough of a load that it can run independently where you're making sure all the safeties are working and stuff like that before you actually start worrying about the liquid going down the cases.
Yeah, correct. And then I'll start bringing on stuff system by system, one at a time. Just bring on a couple systems. And then while you're doing this, the entire time you're monitoring the flash tank pressure and the discharge pressure. You want to constantly keep an eye on that. You want that flash tank pressure to not exceed, 500, 550. And you don't want that discharge getting above 1400. So you just want to monitor while you're starting up. If that flash tank starts rising, shut the liquid supply down, let it pull on the flash tank and just start pulling the refrigerator down and reduce the pressure. You don't want that flash tank to get wound up and then start blowing reliefs. That's how you blow reliefs. And unfortunately, the customer that me and you were starting, they neglected to put the rack controller on the other side of the store and not at the rack. So it has made things incredibly difficult.
Oh, that's horrible.
Yeah, so you're at the mercy of a rack manufacturer that put hardly any gauges on there either.
Well, so the one that I think that I'm probably going to be ending up helping is I believe it's a LMP. So they actually put the controller at the rack.
Oh, lucky you.
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries Serviceable Oil Floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. So we'll see what happens. But yeah.
Yeah, so I mean, you're just constantly watching that flash tank pressure. I mean, just as you're starting things up and you're watching for flood back, just like a hawk watching for flood back.
What do you mean by getting wound up? I don't think I understand.
But you don't want the flash tank pressure to start creeping up to like 550, 600 pounds and getting away from you and blowing a relief.
Well, wouldn't that only happen if the bypass gas valve was not doing its job, correct?
Or the high pressure valve, something happens with it and it opens too far, or
okay.
medium temp compressors get overloaded or shut off on oil. So you want to constantly be watching the oil on this thing too. I mean, you're going to have to add oil a few minutes at startup. I mean, you're probably going to have to add some more oil in there. You're going to circulate oil like no other to start this thing up. So once you start getting a couple systems on, I mean, go slow your first couple times.
That's what she said.
I mean, I've gotten a lot more reckless with it here lately. You usually turn everything on because if it's going to blow up, it's going to blow up. But
I absolutely love your optimism.
Because I mean, it's already a disaster probably at that point anyway. So as I'm doing this, you go a circuit at a time. Make sure you get no flood back. Watch it start coming down. Make sure your suction temps are getting cold. Make sure you're not flooding back. You don't want anything lower than 15 degrees at the compressors. It's going to start pumping oil like no other. So you want to start, slowly bringing them on. Bring on a couple of medium temp loads and then let it run, and then start bringing on some low temp loads, and then let those compressors start, steadying out. Then bring on a couple more medium temp, couple more low temp, couple more medium temp. Just kind of, back and forth. Let the rack kind of, don't overload it at once. It's gonna end up blowing a relief, or it's gonna get away from you. And then at the same time, you're checking all this stuff. You're checking your drop leg pressure. You're checking your high pressure valve percentage. And what you're gonna want to do is just continue to monitor it. And once you start pulling down the temp and everything, this is where you really got to pay attention and make sure that all your EVs are functioning properly. Make sure all the case controllers have the right valve program. The right steps. Make sure everything is looking good on that side. You're not flooding back. Just keep a real good eye on it. And then you're going to top off your final charge. And then you're going to sit there and wait for all the oil issues to start happening as soon as it gets hot.
Why is that?
Because every single one of them has the same oil issue when it's hot.
I don't understand.
They move so much oil, more oil when it's hot, because the turbulence is so much higher that most of the oil drain solenoids and separators can't keep up.
We're okay, because these are sling compressors, so for the most part, so they're slinging that oil all the way the hell around in the cup on that Bitzers, and essentially just that's why it's using so much.
Yeah, and then same thing on the Bitzers. Make sure your hertz is right, because there's a bunch of different ones. So make sure some of them are 25 hertz, some of them are 30 hertz, some of them for the minimum, some of them are 60 hertz, some of them are 80 hertz, some of them are 65 hertz. Just, pay attention to what it actually is. Copeland's are all 60 and 25. I actually like the Copeland CO2 compressors.
Oh, I didn't even look to see what pumps it had on it.
Like we have two stores and they run great. Like they don't vibrate like a 1965 station wagon.
Are you talking about the medium temp, temp Copeland's, and what do they have? Are they actually using scrolls for the medium temp or for the low temp?
The scrolls, and it just explode nonstop.
Oh, problems.
Not a good application for scrolls. I'm sorry. Like all these like smaller racks they're using scrolls. Like we have had more digital scrolls, like DOA on startup, Like the scroll, like the last 3 racks I did, I had to beat the scroll with a piece of wood to get it to finally stop unloading. And then it never did it again, ever. Like all 3 of them did the same thing. They locked up and they would just unload constantly. And then you fucking smack them a couple times with a piece of wood on top. And it would just, I don't know if the pressure just like builds up in there from the initial charge. But
Well, because I literally just put an ad up, and now I have the perfect next Kevin quote, which is basically if it's fucked up, just hit it, just hit it with a piece of wood.
no, I mean, like they've had. I mean, I know Hill Phoenix has had a big issue with them. Like they've had a bunch on startup stick, and then you finagle them a little bit, and they're usually on stick. But I don't know if the pressure gets built up behind the solenoid inside the scroll and just locks it up. But we've had a lot of problems with them. We've lost a lot of digital scrolls too. I mean, it's on the cusp of their operating thing too. I mean, they're 410A scrolls. They're not CO2 scrolls.
Oh yeah, that's right. Because I mean,
it's close, kind of, but not really.
no, I get it. I mean, the pressures are comparable. You know, the 200. Well, no, not really.
Not really.
I mean, no. I mean, it's less of a compression ratio, but I wonder what it. I mean, it's increasing the capacity by doing that, but I don't know how a scroll does that with not much of a differential. You know what I mean?
Explain this to me. How do you have a 410A scroll rated for RL32 oil running with a Bitzer that's rated for BKE 85 oil on the same rack? What oil goes in there?
I've seen that happen with.
Nobody ever wants to respond to this question.
Well, it's the same thing when I've seen Carlisle's on the same rack as a Copeland, that they put in a Copeland satellite. I'm like, oil? I didn't know what. Oh yeah, that's right. They do take 32 oil. Okay.
It's BK85 is what they're putting in there, but all the cold.
Well, does the CO2 thin it out somehow?
No. So that's one thing. It becomes a nightmare with that shit. The BK85, the Hill Phoenix owns like the entire stock of that shit in the U.S.
Oh really?
Yeah, it's a nightmare to get. The French Canadians got a ton of it in Canada. But, yeah, so I mean, getting the oil in there, and then when you go to add the oil, I don't know who.
That's me. That was you.
When you go to add the oil, since it's running, you're gonna want to blow down the oil reservoir, and then blow it down to like 15 pounds of pressure. Valve it off, blow it down, and then you're going to add as much oil in there as you can, and then add it back. Add the pressure back.
You're saying so you don't have to pump crazy amounts of pressure against it, right?
Yeah, unless you really hate whoever is doing that with you.
Don't tell them to pump it down and just make them do it that way.
Oh yeah, I had some guy who was being a real dick to me, and I told him to go up there and add oil and tell him how to do it, and I just let him struggle with like 500 pounds of pressure trying to pump it in there.
You're an asshole. You didn't even give him the hydraulic fucking pump.
Nope. Gave the old hand pump. The old yellow jawbreaker. But no, that's like the basic startup. Like you want to just your biggest thing is watching the flash tank pressure, watching the discharge pressure, making sure you're not overloading the compressors in the flood back. And then you're going to want to just watch it until it comes down. I mean, the low temp, obviously, you're going to have to stage it down. I usually end up floating the suction up a little bit on the low temp before I do anything. So that way it's not, obviously, your bigger loads, your bigger phasers aren't going to be online. So go ahead.
So give me the amounts. So we know that the medium temp can ride by itself, right? We can run that just off the flash tank. How much load would you say that you wanted because of the case issues of actually getting them in at the right time? How much load would say that you'd estimate how much that you could have potentially on the medium temp before you actually able to start the low temp?
I mean, you could start it with just the low temp. You'd be fine. Because I
Okay.
mean, the flash tank's gonna be your medium temp load. It's gonna cycle like shit, but I mean, it'll run.
Okay. Because
The low temp load too. So
no, I get it. I just so you don't have those cycling issues. Like I've heard anywhere from 30 to 40%. They want to, at least on the medium temp before you start checking off the low temp circuits.
it depends. I mean, if you have a VFD and a low temp, it's a lot nicer. Or, I mean, most of the time the digital scroll like runs like not very good. Just kind of all over the place. But like on the actual medium temp itself, you're usually good, but with just starting it up like that. I seen that picture.
What's that?
I just seen that picture. So yeah, I mean, but I'm not starting a CO2 rack up unless the whole thing's piped. I'm just not doing it. It's not getting done. I'm not rush starting a CO2 rack. I'm not rush starting, skipping over steps. I refuse to do it anymore because it's going to end bad. I already know what's going to happen. It's going to end bad. I'm not starting up a rack and the CO2 rack with cases missing because I'm going to tell you right now, all those ball valves weep. None of them hold. They all weep. So you're not going to hold a vacuum. You're not going to, hold a pressure test. You'll hold a pressure test, but you're probably not going to hold a vacuum. You're going to go to start this thing up, and it's going to be weeping CO2 out. So I refuse to, unless it's all piped and ready to go, it's not getting started up. This piecemeal stuff never ends good.
Is it because it's just because those ball valves leak? So trying to make sure that you did a good pressure test on the shit you just piped in just goes horribly wrong.
Oh, that and the good vacuum, and I mean, if the ball valves leak, now you're blowing down an entire loop and you're losing a bunch of CO2. So you're gonna want to just make sure it's all piped and ready to go. I mean, I just had a store we just refused. We pushed start back a week. I'm not doing it. It's not ready to go. It is physically not ready to go. Like we haven't had time to go through and do the validity checks on all the cases and everything else. It's just not happening. So it's.
Oh yeah, I guess getting everything. I mean, because one thing we didn't talk about is getting the cases. You said programmed, yeah, but getting them all communicated, which sometimes is a major bitch.
Yeah, like all these like places that like, oh, we're going to use this case controller on this one because it's Modbus and they're selling their own case controller. We're going to use this case controller it's BACnet on this one. Then we're going to use this case is going to have proprietary controls on this one, and this case is going to have some random controller that nobody's ever heard of, and there's real information on it. And try to make them all talk to a 19-year-old controller.
I feel like I brought up a rough subject for you.
Yeah. So, yeah. Let's take a 19-year-old controller that has like the memory of a Nintendo Game Boy and expect it to communicate with stuff that was made in 2021.
You just gave me another idea.
The truth, I mean, they're just pushing this stuff to the limit here. Then you got Danfoss. Don't even make me bring up that.
We still need to get Yoder on here. Wait. What controller are we talking about? Because I saw like these
800, 880A, anything with an 8 in it they make.
So the new 726 that they're using for the high pressure valve and the bypass valve, you're okay with that one?
Actually, I've yet to use the 726 yet.
Yeah.
Because it's very expensive. The 326A is a great controller.
But I thought they were shying away. They were going to start just going with the 700.
They can't get them. But I'll tell you right now, there's nobody out there that makes a better controller than Microthermal with that. They got everybody beat. Hands down. Like nobody can beat them.
Well, is it because of their algorithm? Like how tight the control is on there?
Their algorithms are better. Their valve control is better. Remember, like I like their flash gas bypass valves better too.
So Microthermal and Sporlan are they're co-owned company, right? Because they're both owned by Parker, correct? Yep. So someone asked me today. I was talking to someone. He had a S3C that was he's like, oh, I think the PID is messed up. I was like, man, the algorithm on that is like basically the same thing as the microthermal. I don't think that it's that. And then we come to find out that he has a valve that I think is like 3 times the size of what he actually needs in there because he's using the PWM valves, the pulsing valves. And basically it was supposed to be like less than 1/4 of a ton. And this thing was sized for a little bit more than a half. So it was just overshooting like crazy. And like, you could see the temperatures in the graphs that he sent me. It was going like 10, 15 degrees above what the fucking set point was supposed to be because it was just overshooting.
I absolutely hate PWM with CO2. It is, you cannot beat a stepper. Like PWM is absolutely trash compared to a stepper. Like you're not going to beat it. Like steppers are so much smoother.
Do you well, let me ask you a question. If they would actually use them with EPRs.
Yeah, I mean, but that's the problem. Like all these case manufacturers are like, buy this because it's going to be the one size fits all, and don't buy you don't need an EPR. And then come to find out later, like all the lines in the store are shaking like an earthquake.
I had and if it had EPRs on it, it wouldn't be so bad. I had a customer a long time ago. I was there and it had one EEV in a certain case that has multiple evaporators in there. So it had one big distributor that was fed by 2 suction temperature sensors. And basically the only way I can get superheat to change, because, we had one valve feeding both, I had to bend the line, basically that was the liquid line to that case, higher or lower if I wanted lower or higher superheat.
That's ridiculous.
They don't do that anymore.
Yeah.
Has 2 coils, needs 2 electronic valves. That's just the way it is.
Or if you're Hussman, you're going to sell 3 electronic valves for 3 coils.
Yeah.
And then you're going to sell that portion. Abortion.
So the racks that I've been seeing that we're getting in for a certain customer have 2 controllers in them. So they're using the core link for the primary, and then they have the 326 for a backup.
That's not core link. That's a Dixel. That's a Dixel product. It's an iPro Genius. So, and you're probably not getting a 326 because they can't get them because it's like a 17-week lead time right now.
Holy shit.
So you're probably getting an iPro or you're getting a 726. I'll be interested to see how the iPro, because we're getting ready to start one up. The new iPro does. The old iPro it was absolutely horrible. I did 3 startups 2 years ago where in the middle of startup, the OEM ripped them out and we retrofitted them to 326 because we blew the flash tank like 7 times. No matter what you did, I mean, supposedly it's all redone, so we'll see how it does. Me personally, though, like with microthermal, their own controls, oh my god, it's so much. You have so much more tuning capabilities.
Well, someone that I was just talking to on the phone with somebody because he was having problems with a rack, and I think his the BGV and the HPV were both actually programmed to the E2 because he found the steps were actually programmed wrong on the BGV that was causing that lagging where it like looks like it wasn't controlling, but the valve only had 2,500 steps.
That's using the iPro stuff. The iPro's mod bust into the E2.
Oh, okay.
So,
well, no, I mean, the picture he sent me was straight connected to an ESR board. It wasn't connected to the iPro.
No, the iPro was driving the flash gas bypass valve, and then they were using the ESR valve to drive the high pressure valve. Okay. I've done that at a pinch when we burned out a Danfoss 320 or 726 or 7. I think it's a 7. I forget what it is. It's a valve driver board. I ended up burning it. We ended up burning it out, and then we ended up retrofitting it to an ESR board temporarily. So, but yeah, that's. We'll probably stop right here, and then we'll go into a second half next time and just go over the rest of the stuff.
All right.
There's a lot of little stuff.
Kevin looks like he's dying inside.
I've been dead inside for weeks.
Awesome. All right, guys. Have a good night.
Just when you think this show is terrible, something wonderful happens.
What?
It ends.